are dependent on electricity for almost all our activities through the day. Electricity is very important to make our life comfortable and easy. Let us do this activity. Take a torch, take out the cells and try to obtain light. Is it possible to get light? Why? No, it is not possible to get light. The cells are the source of power. Since they are removed, the torch does not have a source of power. A. Take two small copper wires, join its ends to a small bulb. Join the other two ends of a wire to a dry cell. Observe the bulb. The bulb glows as it draws power from the dry cell. B. Take out any one end of a wire connected to the cell. Observe the bulb. What do you infer? The bulb does not glow. The wire transfers the power from the cell to the bulb. When the wire is removed from one end, the flow of current is broken. Hence, the bulb stops glowing. Let us understand about electric current and circuits. In a metallic conductor, each atom has one or more than one loosely bound electrons. These loosely bound electrons are considered as free electrons. They can move from one part to another part. Since these free electrons move throughout the conductor, they are the charge carriers. Electric current is a flow of electrons in a conductor or the amount of charge flowing through a particular cross-sectional area in unit time. Current flow in a wire. If the metal wire is not connected to any cell or a battery, then the electrons present in it move randomly in all the directions between the atoms of the metal wire. When a source of electricity, like a cell or a battery, is connected between the ends of the metal wire, then an electric force acts on the free electrons present in the wire. Since electrons are negatively charged, they start moving from a negative end to positive end of the cell or battery through a wire. This flow of electrons constitutes the electric current in the wire. The electrons in the conductor move with a certain average drift speed. Actually, the drift speed of electrons for a typical copper wire carrying a small current is found to be very small. If Q be the net charge flowing through any cross-section of a conductor in time t, then current I is given by, therefore, I is equal to Q upon T. The SI unit of charge is Coulomb, C. The charge on electron is 1.6 into 10 raised to minus 19 C. The current is expressed in ampere A. 1 ampere is equal to 1 coulomb upon 1 second. 1 ampere. If 1 coulomb of charge is passing through any cross-section of a conductor in 1 second, then the amount of current flowing through it is called as 1 ampere. Small currents are expressed in terms of milliampere or microampere. 1 milliampere is equal to 10 raised to minus 3 ampere. 1 microampere is equal to 10 raised to minus 6 ampere. André Ampère, 1775 to 1836, the French mathematician and scientist, carried out important experiments on electric currents. His work enabled people to measure the amount of electric current flowing through a circuit. In recognition of his contribution, the current is measured in a unit called ampere. Now we will study electrical symbols and electrical circuits. Electric circuit. A continuous path consisting of conducting wires and other resistances between the terminals of a battery, along which an electric current flows is called a circuit. Electrical circuits are represented by drawing circuit diagrams. A diagram which indicates how different components in a circuit have been connected by using the electrical symbols for the components is called circuit diagram. Electrical symbols used in electrical circuits are given in the table 4.1. A typical electrical circuit is here. The electrons flow from negative terminal to positive terminal of the cell, but the conventional direction of current is from positive terminal to negative terminal of the cell. Let us perform this activity. Take a small torch bulb. Connect 3 cells of 1.5 volt each as shown in figure. Take 2 wires. Connect end D of wire at points A, B and C respectively and observe the bulb each time. Note down the observations. The bulb glows each time the wire is connected to the cell. Now we will study electric potential and potential difference. Is it possible that the lightning can move from ground to sky? No, but you have seen lightning move from sky to ground. Lightning is the electric discharge traveling from clouds at high potential to Earth's surface, which is at zero potential. The electric potential released in this process can be as great as 10 raised to 7 volt. Keep the water tank A at a higher level and other water tank B at a lower level. Join a pipe from tank A to tank B as shown in figure. Observe the direction of the flow of water. Water will flow from A to B, that is, from high level to low level. There are 2 conductors A and B. A is at high potential, denoted by plus sign, and B is at low potential, denoted by minus sign. If they are joined with the wire, the current will flow from conductor A to B. The current will flow from A to B till the potentials of conductor A and B become same. The current will stop flowing if the potential difference between the 2 ends of the wire becomes 0. An Italian scientist called Alessandro Volta, 1745 to 1827, invented the first battery. Volt, the unit of potential difference, is named after him. Let us see what is meant by potential difference. The potential difference between 2 points in an electric field is defined as the amount of work done in moving a unit positive charge from one point to another point. Potential difference is equal to work done upon quantity of charge transferred. V is equal to W upon Q. Electric potential is the electric level. The current will flow if there is potential difference. See these figures. In this figure, the copper wire is connected in the form of loop. No current flows through it. But as soon as this wire is connected to the ends of the battery imposes a potential difference between the end of a loop and current is set up in a loop. IV is equal to 1J upon 1C. The SI unit of potential difference is volt, denoted by V. 1 volt potential difference. The potential difference between 2 points is said to be 1 volt if 1 joule of work is done in moving 1 coulomb of electric charge from one point to another. Small voltages are measured in terms of millivolts and microvolts. Large voltages are measured in terms of kilovolts and megavolts. Students, you try out this activity and note the observations. Take a copper, aluminium, and glass rod. Make the arrangement as shown using connecting wires. Place a copper rod in the gap AB. Close the key and measure the current. Replace copper rod with aluminium rod and glass rod. Measure the current each time. Note the difference. Let us perform this activity. Set up a circuit as shown. Use nichrome wire resistance R. Take 4 cells of 1.5 volt each. Nichrome is an alloy of nickel, chromium, manganese and iron. First use one cell. Note the reading in the ammeter and voltmeter. Now connect 2 cells and take the ammeter and voltmeter reading. Repeat the above steps for 3 and 4 cells in the circuit. Tabulate the result as follows and find the ratio of V and I. Till now we have studied current and potential difference. Let us find the relation between them. Electric current is the flow of electrons through a conductor. When the electrons flow from one part to the other part of conductor, they collide with other electrons and also with the atoms and ions present in the conductor. Due to these collisions, there is some obstruction or opposition to the flow of electrons through the conductor. The property of the conductor due to which it opposes flow of current through it is called resistance. It is numerically equal to the ratio of potential difference across its ends to the current flowing through it.